Now I'm going to show you how you can use Novi's forecast engine to kick off a pre-drill forecasting set, and I'll review some of the results. So I'm starting here in forecast engine. You've probably seen this more often or more used to seeing it from the pre-drill side, and we have various configuration elements that can help you out there. But I'm going to hop over to PDP forecast here and go ahead and kick off a job. And first thing you do is you give it a name. Pretty simple there. Second is you choose a model, and so in this case we'll grab an autoregressive model. We've got 9,000 wells in the Midland Basin that we'll be forecasting here, and we're using 80 features. That includes things like geology, prior production, which is featurized, completions, well spacing, etc. Next up, I'll hit next. I'll go to the EUR extension model. So if you saw in our blog post, you have a lot of configuration items. Some of those are actually related to the hyperbolic curve that we use to get out from the edge of the machine learning predictions out to kind of later in the life of a well. And of course, you may only be able to go out to 8 or 10 years old in the life of these wells with machine learning or other kind of data-driven approaches. And so this gives you a way to get an EUR that's consistent with other industry methodologies. Next up, you choose a confidence interval. So this is pretty critical and also something that's relatively unique to the software, at least our methodology for doing it. So we allow you to choose up to 2 confidence intervals. You can set what those are, and our software will use, we run an algorithm that basically estimates the uncertainty around any given forecast. And we're going to spend a lot more detail on that in a future post and future video, but I did want to show that functionality there. So finally, give it a name, kick off the build, and it's going to go out into the cloud and run that forecast set for me. As always, we're leveraging cloud compute to be able to make these, extremely accurate forecasts much faster than you'd be able to do on your desktop or even an overpowered workstation. So next up, I'm switching over into Spotfire, and I'm connected in a Novi cloud into a run that I've already done. And so we, work with a lot of clients with a lot of different business intelligence clients, Spotfire among one of them, just showing you this here. So all the data is sitting in Novi Cloud. And what I have over here on the left is a map of the wells in the Midland Basin that were used for our forecast. We've got around 9,000 horizontals we're making forecasts for here. One of the advantages of a machine learning approach is that it can make forecasts for many wells very quickly. And so here I've highlighted Crown Quest. We have hundreds of wells, oil and gas forecasts. If you wanted to say, get a set of forecasts for that kind of eastern part of Martin County, relatively hot area, just highlight those and there you go. So large numbers of forecasts all generated at once. But next up, I want to kind of introduce a concept here, and that's of the time machine, and that's what we use for really a lot of our evaluation of both our PDP forecast and for our post-drill forecast and for our pre-drill forecast. So here we have a cutoff date in, I think that's June 2019. We have in black the actual production data from before the cutoff, and in gray we have actual production data from after the cutoff. So we'll use this for both pre-drill and post-drill a lot of times, but we'll essentially snip the data at that cutoff date, train the data on the data from before the cutoff date, and test it against the data that it didn't see from after the cutoff date. So we're essentially approximating a real-world scenario. And so what I have here is I've selected 6 wells in the basin. And in black, we have the training data, the actuals from before that date. We're looking at oil production. In gray, we have the actual production data from after the cutoff date, so the model did not see that. And in the green, we have our model forecast. So I selected these 6 wells because they can show you really what is one of the main strengths of a machine learning approach rather than just a curve fitting, is that if you're in a scenario where you have limited production data, maybe you're just within the first 90 days, maybe you only have a partial month of production, or if it's kind of noisy, difficult to get a fit, that you can rely on other information to establish an expectation of what the well should be producing. And so for each of these, you can see that despite the difficulty of forecasting a well like that, our models are actually doing quite well and getting quite accurate. I'll show you a different view here, and these are of older wells that are showing not exactly a hyperbolic decline behavior. So these are later in their lives. Let me switch the x-axis here to be log time, and so we're seeing basically non-hyperbolic behavior for a lot of these, where the actual production is kind of starting to turn over, and they're declining maybe faster than you would expect which obviously is bad news for your production, but the good news is that the model is picking up on that pretty well. So this is another example of the type of decline behavior that you might not have good vision to if you're just fitting a standard decline curve. We also generate confidence intervals, but these is going to be a focus of a later video, so we'll go into more detail. But we have some wells that are younger where we have wider confidence. Some wells are older. Of course, that confidence really increases, and you have a very narrow kind of band of what your later day production data for that is. And like I said, we'll spend more data on that in the future. Finally, I want to wrap up here with just a view of how accurate these forecasts can be. So what I've got here is a series of the main operators in the basin. So some of the biggest operators in the Midland. And this is showing you on the y-axis where we have a box plot of errors, and this is how accurate our model was after the cutoff date on the incremental cumulative production. So that's how much the well is producing beyond the cutoff date. And for the vast majority of these wells, we're falling within 10% of what it produced, and furthermore, the main component of that is actually falling within 5%. And you see down here the median error. I definitely want to highlight that. We're looking in the low single digits. 0.4%, 0.9%, minus 0.4%, 0.1%, and that's a good indication of the overall bias of the pipeline, whether we're under forecasting or over forecasting, and we're pretty much some of them were a little over, some of them were a little under, but that gives you real confidence about how well the pipeline is doing at forecasting. And having that kind of average well landing pretty near zero is really important to make sure that in the aggregate you're not over or under forecasting. That's really one of the big ones that we see. Standard methodologies, with reservoir engineers hand fitting it, or even auto fitting things with a decline curve software, where we see a lot of bias be introduced. So that's just a quick overview of our software. Happy to go into more detail about our algorithm, or show you some more detailed results. Just reach out on our website, or send us an email at intro@novilabs.com. Thank you for listening.